Hello, so today we are doing this problem called convert sorted array into binary search tree. So the problem says given an array where the elements are sorted in ascending order, we want to convert it to a head balanced binary search tree. And so a head balanced binary search tree is defined as a binary tree in which the depth of the two subtrees of every node never differ by more than one. And so we have this binary search tree and we want to turn it to this, okay? So my guess is we will just, so let's say we have something like this, right? So something like this, what we'll do is we can just get the middle, make that the root, and then recurse on this, making it the left subtree, recurse on that and making that the right subtree, right? And so we need maybe some helper because we'll need to pass maybe the indices of the start and the end, right? And we of course need to pass the node. And then here we could have a tree node and return that. So I'm not sure if we need to pass like the tree node, but we know that we need to pass a node here, and we can just create it and give it the index. So maybe start here and end. And then the index would be the middle, so it would be end minus start divided by 2. And then we could make that the root, and then the node left subtree would be just recursing and going for, so this would be the mid here, right? So it would be from the start to mid minus 1, right? And then the right subtree would be from the mid plus 1, the rest of the array to the end. And when do we stop here? What's the stop condition is, of course, if n start is bigger than end, right? And at that point we should just return none, okay? And then here we'll return the node, and I'm guessing we'll just say return helper. We'll start with 0, and end would be the length of the array minus 1. So basically just take the mid, make it the root, recurse on this, making it the left subtree, recurse on this, making it the right subtree. Seems there is a problem. Let's try again. So how about just making it, if they are equal, then we could just return this, okay? What's the problem? Let's see. Seems like at 0 and end minus 2. Yeah, so why are we passing as end minus 2 here? Minus 1 here. This is where the problem started. So let's see, maybe it's because of the mid value. and then we got mid 0, and so that's the problem, right? So here we should say max to not go over 0 here, and for mid plus 1 here, max, or actually we should take the min of end in this so that we don't so that we don't go over basically end here. Okay, so seems like we still get mid to be -2 for this case when start is bigger. So actually we should also get out if start is bigger than end, which is just return none. Okay, I still have so actually this would fall under start bigger than end, right? So we don't need this, and this same thing will fall under that if it's bigger, so we don't need this. Now let's try on a simpler input here. So let's just try on an input with just 3 elements. Or let's even go simpler than that, and let's try on just 0. Okay, so that's fine. Now let's try on just -3, 0. Well, isn't it a binary search tree? And so the left should be smaller. So technically it should be this. So this is wrong, right? Oh, -3 can be the root. Both I think work fine, right? Yeah, both work fine. So now what about with this? Okay, so here I'm missing -3. Oh yeah, the problem is this here. That's the problem. I should do this for the right node. Yeah, that was a silly mistake. Let's try again. Okay, now if we try on this one, okay, there is a problem there. So this is normal. Then for mid plus 1, so we do start here, and then mid -1 here, and then we do mid +1 here, and end here, right? And then we recurse, and so we get a new array like this, 10 - 3, where with 2 elements, let's see what would happen with this. Okay, so maybe this difference is kind of the problem here. Does this change how it works? No, it doesn't, so yeah. Okay, what if we do kind of post order? Now we still need the mid here. Oh, and the node is not created, that doesn't work. That's a silly one. Okay, so we have, so if it's bigger, we definitely want to return none. If it's equal, we want to do this. We take the mid element, and then we go left and go right. So this, I mean, this should work fine. So let's run this and see. Let's take this example here. Okay, so that works. That one works. Let's try this one. It's weird that it says maximum recursion here because we are passing just the value, right? I'm going to try to do this differently without a helper function. So let's just say we want to start like this and then just pass in the numbers here from 0 to mid -1 to mid, right? This would end at mid -1, and then we could just here pass in nums mid +1 to the end of the array, right? And since now we are passing the array updated here, we don't need to pass boundaries. So here we can just check the length instead. So let's take n to be the length of the numbers, and then here we can check if n equal to 0, we should return none. If it's equal to 1, we should return that and just take the first one. That's the only element there. And here we can just divide n by 2, and that's the mid. So let's see. Actually, I need to call the function itself, so that would be self dot. Here too, it would be self dot this. Okay, so that looks better. Submit. Okay, so that passes. Yeah, I don't know what was wrong with passing the start and the end on the helper function, but this passes fine, so that's cool. Let's quickly take a look here at the discussion section. Okay, so this is similar to my solution here. The only difference, so they are doing this thing, checking start bigger than end. They are not checking start equal to end because it's already done here, right? And then returning the, yeah, it seems like it's the same. Same thing here. Yeah, actually, that's small detail here. I don't need this 0. I could just do it like this. Okay. Okay, so this is a stack solution. We should take a look at that. Okay. Yeah, okay. So that sounds like it was correct. Thanks for watching and see you on the next one.